Hello and welcome to this presentation entitled Apps for HID Devices. My name is Arvind Iyer, and I'm a software development engineer in the device connectivity team in Windows. I've been working on device technologies and driver technologies for well over 5 years now. I started back in Windows 7 on working on sensor devices and on the sensor and location platform. And since then, I've been working on related areas, and for Windows 8 and now for Windows 8.1, I've been working on more closely with input devices and more specifically technologies related to HID. When we talk of HID, we think of things like keyboards, mice, touchscreens, and like I mentioned, even sensors. So since I've been working mostly on the low-level side, with Windows 8.1, we've introduced these new runtime APIs that let you develop store apps using HID. So in this talk, we will cover some of the technologies that went into building these APIs and how you can use them to write your own device store app. Here's an idea of the topics that we will be covering, sort of a taste of things to come. We start with a brief overview of what is being introduced for device apps for Windows 8.1, sort of a 10,000-foot view of things. Followed that, we will show you a little demo that gives you a little bit of insight into what it takes to write a store app that works with these custom devices. And we'll show you a really cool HID device when we do that demo. And then we get into the thick of things. We'll show you the pieces that are required to build the app. And by the time you're through with the end of this presentation, you will discover that it is easy, in fact, super easy to write apps that talk to your HID device. All right, so let's start with the overview section. Before we go in depth into the tips and tricks and the tools you require to build this app, let's cover some basic prerequisites. This is a 400 level talk, so we kind of assume you have a basic familiarity with HID, and working with HID devices is sort of expected. So we don't cover some of the fundamentals of and concepts of HID. Instead, we assume that you have, and we have a few links up here that will tell you where to go find that information. There is also a very informative video tutorial done by yours truly that can get you sort of caught up or get you started with some of the techniques and the technologies that are presented in this talk. And since we are talking about Windows Store apps and we are in the realm of the Windows runtime, brushing up on some runtime fundamentals and some familiarity with concepts is also expected. And these are some of the things that you would like to sort of get your hands on. Async operations, working with data buffers and streams, and fundamentals, a little bit of fundamentals of devices and how to operate and work with them. So let us give you an idea of what exactly or what does the landscape here look like. In Windows 8.1, we introduce what we call protocol level access. So what protocol level access allows is it enables apps to talk to a device that implements an industry standard protocol. And when we talk of an industry standard protocol, we mean HID, USB, Bluetooth, Wi-Fi Direct, etc. And these protocols have in-box support in the OS. In other words, Microsoft provides device drivers that let you talk to one or more devices that use these protocols. So what does it mean from an app perspective? So from an app perspective, if you have a device that conforms to one of these protocols, you should be able to write an app that communicates to these devices. Of course, there is the notion of an app level protocol, but that is independent of, how the device is connected or what technologies that it's built on. The app protocol itself can be private, or it can be public, so that hardware developers can publish this protocol to enable what we call an ecosystem of apps. This will enable these developers to write apps for their cool hit devices using technologies that are simple and easy to use. So here's a little blurb that highlights the new experiences that we have built in Windows 8.1. Device discovery is built in. This is not something new per se, but we'd like to still point it out because the Windows runtime has a consistent and clear model on how to discover and enumerate devices that are plugged in to your PC. There is a single consistent model in the Windows runtime for finding and determining access to the device, and that comes in with a unified user experience. Of course, there is a new Windows Runtime API, which we're going to talk about in this presentation, which will simplify communicating to and from your device. And finally, and this should be good news for a lot of people out there, especially ones that are developing apps for the Windows runtime, no more custom drivers. You do not need any more custom drivers if your device conforms to, like what we mentioned in the previous slide, a consistent and a well-known device protocol. So here's a sort of an architectural view of what we are going to be covering in this presentation. We are going to be talking about Windows Store apps and device apps in particular. So here's the classic picture that you probably are familiar with, which shows the Windows Store app residing in the app container. This is the topmost layer of this layer cake that we build here. The new runtime API, which is the windows.devices.humaninterfaceDevice API, is hosted inside the app and in the app container process. And there is a access broker, which is not an app container, but this is what gates access to your device and allows the user to be in control at all times of the experience between the app and the device. The runtime layer, which is the API layer, talks to the native HID layer, which encompasses, the Win32 libraries as well as the class drivers. There are a bunch of kernel mode components, and all the way to the bottommost layer of the cake, which is the device itself. All right, so that was like an overview, and now we are going to give you a little demo into what exactly we are going to be building and what you can do using this API. So here's our demo. We can see that it's a really simple device. It's called a missile launcher. It's a USB desktop device that will shoot darts at you. So first things first, we need to start the app that will talk to the missile launcher that we have here. So let's go ahead and do that. And you can see that it's a fairly straightforward HID device. It has a bunch of motions that it can do. It can go up and down, it can rotate left and right, and pretty cool thing about it is it can fire darts. It's not as scary as it sounds. So the first thing we do is we will try to connect to the device, which I do by pressing this button here, and immediately you get this consent prompt that we alluded to. So at this point, the user has a choice that he is now allowing the app to access his device, which we are, of course, going to allow. And you can see that the status says that the device has been connected. Gives you some additional information like the vendor ID, the product ID as well. So let's play around with this and move it around a little bit. So I'm going to just move it up. As you can see, it moves up, it moves down, it will rotate left, it will rotate right. And let's fire a dart and see what happens. Since you can see, it's going to fire. All right, now that you've seen the really cool demo and that gets you really excited about building your own app, let's move on into what it actually takes to build an app that'll work with your device. So the way we've structured the remainder of this talk is to provide like a step-by-step walkthrough of what it takes to build a device app that will talk to your HID device. So the advantage of this will become apparent because there are a few key pieces that you have to get successfully right in order to be able to communicate to your device. And here's a little flow diagram that shows what it takes to actually, what are the pieces that are required to actually go through and build a device app. So this is what we call the accessing devices in the Windows runtime flow. There are 4 main steps that apps will tend to follow in order to get started. The first is to declare a capability. So think of the capability declaration as sort of a means to express the app's intention of what it will use. It could be some really high-level construct like the app needs to access your location, or the app needs to access the internet. But since in our case this will be a device app, it tends to be more specific and tailored to the device. Hence, it will be a device capability. Next, we need to obviously find and instantiate the device that we're interested in, which means there is some means of discovery. We'll go into that a little bit. So once we have the device, obviously, we want to open it or talk to it, communicate with it, which is communication. And finally, when we're all done, there is cleanup. So let's go into the capabilities first. So like we mentioned, a device capability expresses the app's intent to talk to a specific or a more generic kind of device. For HID, there is a top-level device capability, and it's simply the expanded name of HID, which is Human Interface Device, which is sort of the first thing you have to put in your app capability or your app manifest. Within that, there are 2 sub-capabilities which further detail or give more information about the device in question. Specifically, there is a device ID portion, which identifies a device using its vendor ID and its product ID. And the function type, which describes the usage page and the usage ID portion of the top-level collection of the HID device. As you probably know, a single HID device or a single piece of plastic can have multiple top-level collections, and so an app needs to know which top-level collections it needs to have access to. And this is what the function type actually describes. So how do we go about finding these properties like this vendor ID, product ID, so on and so forth? Well, there's a simple tool that is included in the WDK called HClient, which has been there for a while. And HClient, as soon as you bring it up, it gives you a view of, and there is a drop down in which you can select your particular device. And if you look at the device attributes, it gives you its vendor ID, its product ID, as well as the usage page and usage ID. So once you've identified which is your device, you could just grab this information from HClient and you can plug it in straight into your app manifest. And these are the key properties that you will need to extract from the device in order to declare its capability. A quick caveat here is that people tend to look in Device Manager for this information, but since this is specific to HID, Device Manager may or may not have the right information at all times. All right, so now that we have this information, we need to figure out where to put it. And the place to put it is in your app manifest file, which is included as part of your store app solution in Visual Studio. So find your Visual Studio, and there should be a default package.app manifest file, and open it, but don't just open it in the default editor, open it in the XML text editor because we need to edit the XML text in there. And here's what it looks like when you plug in all the information that we got from HClient. As you can see, we've declared the top-level device capability, which is Human Interface Device. It shows the device ID fields have been populated with the vid and PID, as well as the function types using the usage page and usage ID. Now, you can get creative with this, and you can have, if your app needs multiple device capabilities, it can do that because it's an XML blob. You can add more than one device capability. You could mix and match. It doesn't mean that you can just use only the human interface device capability. You could use location on top of this. The point here is that you need to describe ahead of time what kinds of devices your app needs access to. So in this example, we show you a slightly different way of describing it, where we said this is perhaps a game simulator and it wants to talk to all game devices. It doesn't really know its vid and pid. Therefore, it just describes it using its top-level collections usage page, which is 0002 and 0003 in this example. So a point here that we should note is that the new runtime API is for use with fairly custom peripherals, custom HID peripherals. So here are some what we call commonly allowed top-level usages. This is not an exhaustive list by any means, but some of the common top-level collections that we see in these custom devices. So just something to keep in the back of your mind. There are a set of usages which are allowed to be accessed, and there are certain which are not. And here are some that we allow by default. All right, so now that we've described or declared the capability for the app or its intent, the next step is obviously finding the device, which is device discovery. Let's see how we can accomplish that. So in order to find the device that we need to go through the process of enumeration or discovery in more generic layman's terms. So the way we do that is we start with a selector. A selector is nothing but a string which uses a specific syntax called AQS, or Advanced Query Syntax. For the HID APIs, there are a couple of sort of pre-made static selectors that you can use, and you can get access to them using the getDeviceSelector methods that are part of the HID device class. So you can call getDeviceSelector using a usage page and a usage ID, or you can use a usage page, usage ID, vendor ID, as well as a product ID in order to get really specific. When the device selector returns, it gives you a string that you can directly pass in to the windows.devices.enumeration APIs, more specifically, the find all async or the create watcher methods. What that does is it uses the selector string that you've just passed in and tries to find all devices on the system that meet the particular selector criteria. So once find all async returns successfully, what you have with you is a collection of device information objects. Each device information object is a representation of all the devices in your system that met the selector criteria. So once you have a collection of device information objects, what you need to do is open the device so that you can start communicating with it or send I/O to it. And the way you do that is you call fromID async on the HID device class, and you pass in the device information.id. What fromID async is essentially doing is calling open or create file under the covers to open and give you back a handle to the device. So let's see a code snippet which sort of goes over what we just talked about in text. Here you can see that we use a getDeviceSelector method, gives you back a selector. We pass the selector to find all async. It gave you a device information object or a collection. And when we want to open the device, we call from ID async, passing in the device information.id as well as an access mode. We'll talk about the access mode a little bit. A point here about calling from ID async. The first time the from ID async call is made, you have to do it on the UI thread. And why is because when we try to open the device under the covers, the user is presented with a consent prompt, which he or she has the option to allow or block access to your device. And we remember we saw the same consent prompt when we did the demo. So in order to make sure that the user sees this consent prompt, you must call from ID async on the UI thread. So be aware of that. So once from ID async returns successfully and the device object that you get back is not null, you can sort of start doing I/O to the device and communicating with it. So just to make sure that we drive the point that we were making earlier home, when we call from ID async, there are a few runtime checks that are performed under the covers. First, we check for the capability declarations. Remember the intent that you expressed in the app. Second, we make sure that the device that you're trying to access is one that we allow access to. In other words, it's not something that is conflicting with existing OS behavior. For example, we don't want you opening a keyboard or a mouse, for example, for obvious reasons. We also check that the app is already not been the device has not been opened by an app already. In other words, we make sure that if you want access, it's not been previously exclusively accessed by another app. And finally, we display the consent prompt. Now, if any of these criteria are not met, what from ID async returns is a null hid device object. And you should be aware of that. You should be able to handle that situation. So what happens when the hid device object is null? It means that one of the 4 criteria that we just mentioned has failed, and hence you are not going to get access to the device. Now, if you so desire to find out what exact reason why the device was null, in other words, one of those 4 criteria were not met, you can call this other API, which is device access information, and it gives you back an access status, which you can query for to figure out what is the exact reason you were denied access. This is not a must-do. It's an optional additional information in case you want to display some text to the user. But you should be aware that the device object that you get back from ID async call could be null. So a quick note on access mode as well. When the device is open, we also specify an access mode, which is either read or read and write. And the thing to note for HID is that reads are always shared and read-write is exclusive. So if you want exclusive access to your device, make sure you open it with read-write. All right, so we've described the capability. We've found the device we wanted. What's next? Well, we need to communicate, of course. So let's see how we can do that. All data flow in HID, as you are aware, is through reports. Reports are containers for data buffers. You fill in a data buffer with the bytes you want, send it down to the device, which knows how to process it, and vice versa. When the device has something to send, it will fill in its data buffer, the drivers will get filled in, will fill in that data buffer, and pass it all the way up to your app. There are 3 types of reports in HID: input, output, and feature. And they each determine which direction the data flow is on. And they also specify, whether it's feature reports are unique in that they are bidirectional. They can be used for configuration and settings typically. So let's take a look in code as to how you would retrieve or send each of them. First of all, we should note that all device communication is asynchronous. That is, I/O is submitted in a non-blocking manner using async operations under the covers. So the results of that are available through the result and the status callback that you get from an async operation. With that in mind, here's how sending an output report and getting a feature report looks like. It's fairly a straightforward process. You send an output report, you create an output report, you can pass in an ID optionally if you want. Then you have a data writer because you're filling in the data buffer inside the report. And you fill in the byte pattern that you want, include the report ID if you want. And you just call send output report async and pass in the output report. And when the async method returns successfully, that means the output report has been sent to the device. Retrieving a feature report is just the opposite. You call get feature report async, and then it gives you back a feature report. And then you use a data writer to extract the buffer that the report contains. And you can see that the report ID is typically always the first byte, and then the byte pattern, the byte buffer that you have in it is whatever follows it. So let's look at it from an input report perspective. An input report, remember, is what the device sends you. The async methods which we saw in the previous slide, features report and output report, typically reflect the existing state of the device or the current state. On the other hand, a change of state is what is reflected using input reports. Therefore, it makes perfect sense for input reports to be event-based, which is exactly what this code snippet shows you to do. We have an event handler called input report received, and you can pass in your event handler to this. And when the device has an input report to send, your event handler your callback is invoked, and you get an input report that you can process from it. And the processing of the input report is similar. We just show you a slightly different way where you can actually use an iBuffer and get its length and so on and so forth. So that's really the nuts and bolts of communication. You know how to get an input report, get input reports. You know how to send output reports and get or send feature reports. With that, you should be able to do all communication that you want with your device. But there is one more thing, which is closing the device and cleanup. So you should be aware that when you're done with communication, you should go ahead and close the device. And there are a few things to be a little bit aware of, which are language-specific nuances about object close and deletion. And we show you an example of how you would do that in all the three languages. For example, in C++, you don't need to do an explicit close, but you just delete the device object and just set it to null, and you're done with. However, in C# and JavaScript, it's a little bit different. So just be aware of these subtleties when you go ahead with this. The other thing that you should also be aware of is app suspension. And the takeaway here is that you must register for app suspension. And you may ask why. And the reason is the actual device object that you use when you're doing communication gets invalidated when the app gets suspended. It is recommended that you go ahead and close the actual device when you get the suspension callback and reopen the device or reopen the handle to the device when in your resume callback. You should also be aware that once your app gets suspended, you have 5 seconds to make sure you do your necessary cleanup. So don't send any new I/O in your suspension callback. So remember, the missile launcher was a fairly straightforward USB hit device. We used to be connected to it, and then we played around with it a little bit. We made it rotate, move up and down, and fire missiles. So the first thing we did, so if you remember from our earlier slides, was we connected to the device, and that's exactly what we're going to show here. So what we do here is show you how to connect to the device, and here's a code snippet that shows you exactly what you need to do that. So remember, we create an AQS string using the getDeviceSelector method, and you can see that this is exactly what is happening here. we call get device selector using the usage page, usage ID, vid, and the PID. The second thing we do is called find all async using the selector. And finally, we have a collection of these device information objects, and we call from ID async on them. And we call it with a read write access mode. And that's it. So you got connected to the device. So the next thing we did was once we connected to the device, we sent it data. And the way the missile launcher works was we send it a bunch of output reports. And the protocol is fairly straightforward. You just send it an output report it's a single byte output report. So you just send it what we call commands. So you fill in a byte and it sends an output report to the device. So let's show you in code what it takes to send an output report. And again, so let's look at, here's the send command piece. Like I said, it's a fairly straightforward protocol. It takes in a single byte, which is a command. And the way to send that command down to the device is to create an empty output report by calling create output report. Next thing, we have a data writer. We fill in the report ID, which in this case is just 0. We detach the buffer, and then we call send output report async. And if the result is successful, that means the output report was sent successfully to the device. And that's all it took to send an output report to the device. Now, if you were attentive and you saw in the demo, it gave a bunch of status back, telling you what is the exact state of the device and any changes that it was doing. And that was through input reports. So let's visit that piece of the code as well and show you what it takes to get input reports from the device. The first thing, of course, you need to do is to register for input reports. And the way you register for input reports is you have an event handler. So we created a typed event handler, and we used a callback, which in this case is the on input report event callback. And we sent that event handler to pass that event handler to the input report received event, and we just sent a command to get the device ready. So this was the registration, and let's see what happens when you actually get an input report, which is the handler itself. And here is the on input report event handler. You can see that it gets in an argument, which is the input report itself. And then you get that from the event args. You use a data reader to read the byte buffer, and you can read whatever bytes it's sending as far as status is concerned. So since we were going to display it in the UI thread, I'm just calling run async to make sure that it's dispatched onto the UI thread, and we show you the status. So that's it. That's as simple as it gets. So hopefully, between showing you the demo itself and showing you the code behind it, you get an idea of how simple it is to build an app that can talk to your custom HID device. All right, so at this point, you have all the tools and the concepts required to be able to communicate with your custom HID device. So since these are fairly custom devices, hopefully what we showed you up to this point is most likely the path you will take. However, in our API, there are certain advanced communication features which we want to mention. And these are semantics that you will use if you probably don't have a very good idea of what the device is capable of or it can do. Hence, you will use these advanced features behind them and use these advanced semantics and these API calls to discover them. And this is what we call controls. As you may be aware, Windows comes with a very rich HID parsing library that allows you to dig deeper into the HID protocol specification and extract features from it that are not exposed in the normal scheme of things. And the HID runtime API also takes advantage of these parsing capabilities that we have, but simplifies them a whole lot to make sure that they are much easier to use from your app. And this is where we introduce the notion of controls. So remember that all data in HID is via reports, and reports are containers for data buffers. Now, what are controls? Controls are essentially abstractions for the data in those buffers. In other words, if you want to view the data in a different fashion, in sort of in sort of these in the fashion of controls, this is what you would use. So we have two specific controls that we expose in our API, and they are called Boolean controls and numeric controls. As the name suggests, Boolean just means that the data usually represents like an on-off value or a Boolean value. And it's more interesting to look at Boolean controls in terms of their transitions. For example, a switch change state from on to off. Whereas numeric controls are more absolute and linear or scalar. And for them, the values that you really want to look at them are the raw values themselves, which are absolute. So let's show you a little pretty picture which helps you visualize what controls are and how they're represented. So here's a little game controller. It's your standard Xbox game controller. And you can see that it exposes both types of controls. The little face buttons that you have, the A, B, X, Y buttons, and these are your Boolean controls because they can be in the pressed or the unpressed state. Whereas your little joysticks and the D-pad and the sticks on the right and the left, they are numeric because they have X and Y values which are absolute. So how do you use them in your app? Well, it's simple enough. You have an input report, which is typically where you want to parse these controls from. And once you have that input report, you can just call get numeric control or get Boolean control, and you pass in the usage page and the usage ID of the control you desire, and you have its value. So it's really, really straightforward to go and get a control and play around with it. There are more advanced features which you can go and look at in the documentation about how you can use controls and what is their relationship to collections and so on. All right, so that sort of covers everything that you need from a communication perspective, working with the device perspective. We just want to mention a couple of additional features that we have and something that you should keep in the back of your mind when using the API, and some more tips and tricks that you might find in handy. The first is, of course, debugging. You always want to debug if something went wrong. And we have extensive WPP tracing in the API as well as its associated components. We have a link on our landing page which shows you how to get set up with WPP tracing and what trace GUIDs you need to use to start debugging. A note about restricted access. Like we mentioned, this API is mostly in use for custom HID peripherals, so for custom HID devices. PC internal devices can not be generally accessed except if they are through privileged apps, and privileged apps require device metadata in order for them to work. And we enable these apps, these ecosystem of apps, like multiple apps talking to the same device using inbox drivers, HID class drivers specifically. A note about power management. You should know that in Windows 8 and 8.1, HID devices are very aggressively power managed. For example, a USB HID device is selectively suspended when there's no I/O or when there are no open handles to the device. We also power down the device during connected standby, something that you might be aware of. So just to be aware that if there is no I/O, if there's no active I/O going on with the device, most likely the device will be put into a low power state. And this is beneficial for the OS as a whole. And in closing, here are a couple of related sessions that you might want to go look at. There are some pre-recorded talks for them. There is a sister talk which talks about USB access to devices as well. And there's one on Bluetooth and Bluetooth Smart devices. So that's something that you might find interesting. Finally, here are some references. There is some exhaustive documentation on MSDN, which talks about all the API features. And there is a really good SDK sample, which shows you some of the concepts that we covered in this presentation and much more. So I'd highly recommend that you go and download the sample and play with it. And thank you. Hopefully you found this talk informative, and it has been a pleasure to bring you this presentation. Thank you.